Hi, good evening, everyone. Good afternoon, good morning for people from the West. Um, Welcome to the second webinar which we are conducting on behalf of ICMAI. In fact, this is the first technical webinar, first of the many technical webinars that we're conducting. I'm going to share my screen. Tak, let me know when you see the screen, okay? Yeah. Hi, can you see the screen?
Yeah, you're good to go.
Okay. So I'm going to introduce ICMAI, why the ICMAI was formed, how it was formed, and what the ICMAI plans to do in the future. Uh, uh, to give you the background, the main factors were the safety record in India, and also the growth potential for the Indian elevator and escalator industry. In the year 2020, the reported fatalities were 21. Now again, this is a reported fatality. We don't know how much the unreported ones are. Secondly, we don't know how many accidents which have happened which are not fatal. So from our point of view, this 21 is too many. The main reason being the industry not focusing on the compliance, not complying to the standards and to the codes. Uh, not only does the component manufacturing company needs to focus on the compliance, but also the technicians and the installation companies that needs to focus on compliance and the standards and the codes. With this in mind, uh, and the second point being the global quality, which is the global potential. Now, if you look at this graph, India's contribution being the second biggest market on the world to the global export is less than 0.3%, which is a shocking figure, if you ask me. Why? Um, that was the first question. Second, now if you see China as one of the key exporter in the world, India is contributing 5% to China's export. Uh, Export opportunities are vast, and Indian companies have the right opportunity to move quickly. Indian manufacturers have a large capability, but they need to build their quality standards to scale up to the global levels. And also they need to match the global competitive prices. How can this be done? They should also seek the technical upgradation, which can be done via the strategic networking. Manufacturing processes must scale up and will need something like Industry 4.0. The resources are there, the infrastructure is there. We need to scale up to the global level. That's the key. The opportunities that we have. Now, the global E&E exports is approximately 20 billion US dollars, and India's contribution is barely 0.25%. And being the second biggest market, there is a huge potential for us to uh, get as much as into the global export. And with this idea, how can this be done? Like, the main factor being that we support opportunities of domestic manufacturers. We make India Atmanirbhar. By that I mean self-reliant, self-dependent. The local manufacturers can leverage the scale from increased market size to compete with cheaper imports. With this vision, which is to make India the preferred hub for the global elevator and escalator industry, ICMAI was formed on 10 September 2020. This is a Section 8 company, which means this is a non-profit organization. And the mission here being to support the growth of the elevator and escalator industry by promoting continuous improvement of safety and quality standards, education of the community, and networking with domestic and international organizations. There is a variety of tasks which has been put in front of ICMAI. How are we going to do this? We have to enhance the safety, and we do that by improving the quality standards of the components first. Then we adopt the best-in-class practices. Also, we impart knowledge to the individuals and the installations who will be installing these components at the sites. We try to minimize the imports and make India Atmanirbhar. We enhance the export business. We do this by inviting the international trade delegations. We establish relationships with other lift associations across the world. We guard against the counterfeit components. And like I said before, we promote business through our international alliances. And the main thing is we promote friendly exchanges of ideas amongst our members by networking and connecting. Any organization, any association is judged on its strength, and this is our strength. These are the members who have joined us already, and from what you can see, the big names are already in the association working towards our vision and mission. I take the opportunity to whoever has joined this webinar to please come join us. Please become a member of this association. This is the only association which has been identified by the Ministry of Corporate Affairs, which is why they allowed us to use the word Association of India. We are available on all the social networks, LinkedIn, Facebook, Twitter, as well as Instagram. And you can always reach us on membership@icmai.com and on this phone number, which is mentioned here. Like I said, this is one of the first webinars, technical webinars, which the association has planned. And going forward, we have a lot more coming up, a lot more technical sessions, which will help each and everyone who's associated with this industry. With this tack, I give the screen to you.
You could leave the slide on for a minute so that anybody wants to note down the email ID and the telephone number could do that.
Sure.
A minute, and then I will start. We will get on to the session. Thank you very much, Harish. Yeah, I think I'll now share my screen. You can see my screen.
Yes.
Okay, so we are coming to the main session of the day. That is the technical session on understanding elevator doors, safety performance, and fire resistance. Like I mentioned, this is the second webinar that we have. A key aspect of today's webinar is that we have a collaboration of two competitors coming together to talk about their area of specialization. Now, you might wonder why this is a critical thing, because we need to recognize that if the elevator industry does not come together, we will struggle to get quality in place, we will struggle to get safety in place. It is only through collaboration on quality and safety matters, collaboration in education matters, that this industry can become better. Okay. So we, like I said, we have an interesting panel of experts today. Is my mic echoing, or is it somebody else? Okay, I guess we are good to go. So we have a panel of four experts, and the interesting thing about this four panels are they are people who are specialized in elevator doors, which is something again which is a little unique, that you have somebody a group that comes together specialized in one aspect of elevator doors. So I will start with the first and then continue to introduce all four, and this will be a joint presentation. So Arvinda Babu is an engineer with 20 years of experience in product development, elevator doors, tooling, vendor management, development, and project management. He has a wide knowledge in product development, including that of automatic door for lifts, insightful knowledge of various engineering standards and in design, development of new products in conformance to predefined technical specifications. Aravinda Babu works for Fermator. Then we have Sunil Raj, an engineer with 12 years of experience in after-sales department. I mean, it's easy to just sell an elevator door, but the subsequent service is what matters because elevator doors have to survive for the next 20 to 25 years. He's responsible for the after-sales department for elevator doors for Fermator. He monitors the complaint registers of dealers and track dealer performance to ensure that they are performing service interventions in line with the requirements of the products, improving dealer service efficiency, providing training, and to solve various issues pan-India. In terms of achievements, he has been responsible for getting elevator doors fire tested in CBRI Roorkee, TUV SUB in Singapore, according to BS 476, then in Malaysia. And he was also responsible for training and leading the Fermator Chinese installation team to conduct a fire test in CABR in Beijing, China. So that's Sunil Raj from Fermator.
Hi everyone. This is Sunil Raj.
Our third speaker is Deepak Prashant, 14 years experience in the elevator industry. Deepak Prashant is the head of research and development at Vittur India. He started his career as a design engineer and progressed to larger design roles as design consultant, program manager, and now is the head of R&D. He has also worked with MNCs like Otis India and Toshiba. Deepak is a mechanical engineer and a postgraduate in supply chain management. He also holds a certification from Harvard University on launching breakthrough technologies. Our final presenter is Giuseppe Di Francisco. He joins us from Europe. So it's like a good afternoon for him. He comes with 20 years of experience. Again, a hardcore research and development experience. He's the vice president of R&D at the Vittur Group. He's the head of knowledge management, innovation, norms, and intellect property at Vittur Group. He also heads the smart and electronic activities for Vittur products. Between 2006 and 2016, Mr. Giuseppe was the CTO and the member of the executive team at Simatic, a company that Vittur took over and is now part of the Vittur Group. Again, in terms of his expertise being recognized, he is one of the 25 worldwide people appointed to ISO TC 92 on fire containment. I think as the months go on, you will understand what ISO TC and all these sections go on, because we will be having sections explaining this. He's the convener of the ELA WG EN 8158. ELA stands for the European Lift Association. Again, WG EN 8158 is a code that we will be discussing in the months to come. He's a member of ISO TC 178 WG11, the methodology for the improvement of safety of existing passenger and goods passenger lifts. He's also a member of the TC10 WG6 firefighting lift group. So these are the four people that we have, and I think we are pretty privileged to have them talk to us on the area of their competence. And I think towards the end of it, you will realize and recognize why elevator doors has become our primary focus when we start off our technical sessions, technical webinars for ICMAI. Well, with that, I will hand over to our first speaker.
Hello everyone, very good evening to all. This is me, Sunil Raj from Fermator. Now I will be discussing about as we are going to discuss about elevator doors. First, let us understand about a little bit of a history of our elevator automatic doors. So, next slide, please. So, in this view, in this slide, we can see the first image was the first elevator with the door. You can see in the top of the platform there is a small barrier has been shown, which is the first automatic door for this elevator, which was been implemented by George Ackerman in the year of 1881. So in this elevator, we don't have any cabin setup and things like that. It just had a platform, to avoid people or material to fall down from the platform when it's going to move from one level to another level. So this barrier will come down when it reaches the floor level. So there is a gear and counterweight setup has been provided. So with this setup, the barrier will come to the floor level while the lift is in traveling, and it will go up while to unboard from the platform. So this is the initial stage which has been started in mid 19th century. So after the period of time in the beginning of 20th century, the setup of elevator with cabin and doors with a controller has been discovered and has been come to usage. So in this slide of year 1920, which is in which it has been shown us some collapsible gate. So after, like this, little by little, there was a development of automatic doors. In 1940s, there are more mechanical linkages has been incorporated to operate the doors. So in the late 1970s, there was a revolution happened in elevator doors with an electronic module which is help to operate the door to open and close. So this is a brief explanation about our history of doors. So now we will go to next slide. Now we will be looking about the different types of elevator doors which we are using now. There are two variants which is manual and automatic doors. In manual, there are two types. One is collapsible gate, and one with collapsible gate for cabin and a swing door for landing. And same wise in automatic door, there are two variants. One is horizontal byparting, and another one is vertical byparting. Now I will be explaining a little more deeper about manual doors. Okay, so let's go further. So manual doors. So manual doors, it's maybe I hope every participant would have gone through this type of doors even now or even in their young age. So these doors are basically very cheap, low cost and less technology oriented doors. So to install these doors, there is not much knowledge is required, and there is no complicated mechanism or complicated electrical circuit has been provided. So this is the plus point what we can see in this door. And compared to the plus point, we have a lot of negative points, and which are the problems occur in this type of doors. So basically these doors, let me explain something about my own experience in past years. When I was in college, we have a similar elevator in our college, which we used to board very often. As it is a college, there are so many young people will be traveling in the elevator, and most of the time it will be overcrowded. And in this elevator, at least once in a week or once in a month, there will be an accident happening, because more crowded people, some people will keep the hand in between the gates, and someone will try to open, someone will try to close. At that time and all, severe accident will happen. Sometimes bones or chances of fractures are high. So like this, there are many drawbacks has been observed and occurred in this door. And these doors don't have a good security system like landing lock or cabin lock, which is not still it's lock are there, but it is not so reliable. And we can't able to install a light curtain, and these doors are not been fire certified. So this basically it's not so safe to use in current time period. And these doors, as we've seen in the previous slide, in 1920s, it has been similar doors has been used in 1920s. But these doors is now also still we are using these doors, which is a bitter truth now. So can we go to next slide, please? So first, let me show this video so that everyone can have a look about this video. Then I will explain a little bit. I think everyone had.
I'll pause it when you tell me to pause it.
Yeah. Let me run for a few more seconds so that everyone can see this video. Okay, let's pass the video. So this is one of the fatal accident of manual doors. See, in this manual doors, it is not supposed to be opened when cabin is not there. But in this case, it was opened. The reason behind this is the landing lock is should be manipulated, or some short circuit has been done in this door. And the person when he tries to open, it is, if the cabin is not there, it is not supposed to open, but it opened, and he thinks that the cabin is there inside the shaft, and he was trying to step in, and now he is no more. So this is very evident video to show the risk and unsafety of this manual doors. Yes, next slide, please. So this is a very disturbing video. I hope everyone would have watched this before, because 2 months back, this video was roaming in all over WhatsApp groups. I think we can.
I'll probably pause it the first time.
It's very disturbing. So this video, I mean this incident. So this incident has been occurred in last year November month, which was happened in Mumbai area in Dharavi. So in this case, the boy and his sisters were using the elevator. This boy was trying to once they reached the floor level, those two sisters of the boy left the elevator. As these doors have self-closing mechanism, it closed by itself before he exit from the left door. So in these type of doors, manual swing door with manual collapsible gate, there is a huge gap has been there in between the landing and cabin, which is the very bad design of this elevator. So in this case, you can clearly see that the boy got trapped in between car and landing. As this both doors has been closed, the controller will receive as the doors has been completely closed. And in this case, someone has booked the call from other floor, and the lift started moving. Now there is for him, there is no way to go outside to the lobby, or not even to get into the car. So in this case, see this the lift started moving in upward direction, and the boy got crushed in between floors, in between doors. This is one of the disturbing videos. Okay, next. So now we will see how the hands and foots are gets injured in manual doors. See, basically this manual door will. I will let me tell you the how we will use these manual doors. While entering to the while entering to this manual door lift, first we will be opening the landing door, and then we will be opening the cabin door. So after entering, the first of all, we want to close the landing door and then the cabin door. So most of the time, people will be not so conscious about which door we need to close. In this case, if someone closes the cabin door first and try to close the cabin landing door through letting the arms to close the landing door in between the gaps. So once the door gets closed, the lift started moving, and the hands will be totally dissected from his body. So this is how the big major accident will happen. But in this case, as I explained you before my own experience, this when more people are there in this lift, more chances of handling the door is too risky. And even for children's, there is no words to explain. People will lose their organs with this type of doors. And in last years and all, the maximum fatal accident has been occurred with this type of manual door elevators. For example, the last one which we saw the video, and previously there was one more happened in Mumbai, which is also a similar gate setup, one with manual swing door and collapsible gate door. In that case, there was a 11-year-old girl. He's trying to see. There was a vision door, vision swing door, where there is no glass. The glass was been broken, and no one was ready to change the glass. So in that gap, a small girl of 11 years has been looking whether the lift is coming or not. At that time, the lift passed, and it just cut his head head from his body. So that is also one of pathetic incident about these doors. And now, still nowadays, most of the regions in India, we are still using this type of doors. If I'm not wrong, Delhi has been totally stopped this type of doors for new installation. So my humble request to all participants is to avoid using this manual doors, or should maintain it properly with regular maintenance from the trained technicians. So this is what I just wanted to tell about manual doors. So now my colleague Aravind Babu will explain about automatic doors.
Good evening to everyone. This is Arvind here. I will take the explanations about the three areas. One is about the classification of the doors, and to the safety factors of the users, and the safety factors of the technicians, and the standards which we apply on these doors. So these are the three parts which I am going to explain to you. This is the general information about the doors. So the doors, the first criteria, the doors are classified based on the installation type. The first one is the residential type. The residential buildings is mainly used for the application of the passenger movements from one floor to another floor, and it is for the less traffic and the medium traffic. And the second category will be of the commercial one. It is also mainly for the passengers, where there is a high traffic and more floors. That we go for this commercial elevators. And the next one will be for the freight elevators. In case of freight elevators, we'll be having this heavy movements of the vehicles, and the application of these freight elevators will be for the factories, the storage facilities. We like that areas will be using these freight elevators. And the special doors is the main special requirement from this. It's an aesthetic doors, like uh, half round doors. It is a special requirement from the customers for the Bangalore's. This is the first classifications which we done it based on the installations, and the second type which we based on the openings. The doors are also classified with reference to the openings. One is the center opening and the side opening, or we call as telescopic. The telescopic will be having both the sides left and right. So the center opening where it requires more shaft dimensions, and telescopic which is required when there is a constraints on the shaft dimensions. The customers will prefer for this telescopic. And in case of center opening doors, both the doors will be traveling at equal distance. So the left and right doors will be traveling the equal distance, whereas the telescopic, one of the doors will be having a shorter distance of travel, and the faster panels will be having a more travels. So this is the criteria of this telescopic doors. And while coming to the door classification, it is also based on the number of panels. In case of center opening, there will be a 2 panels, 4 panels, and 6 panels. So why we have 3 different of variants. In case of 2 panels, I can give you an example. If the customer requirement is for a clear opening of 2000, so in this case, the shaft dimension will be almost double the clear opening. It should be double the clear opening. But in case of going to the 4 panels and 6 panels, we can accommodate the same clear opening with the reduced shaft. That is why we are having different types of panels, 4 panels and 6 panels. Also, it's also based on the applications. Also, we can do it. The similar way, we also have this. There is also categories of telescopic also. In telescopic, we can go for, that is a designs of 1 panel, 2 panel, and 3 panels. As a basic information, in case of 4 panels, center opening 4 panels is just a combination of telescopic left and right. So this is just a general concept. This is how the panels is being classified based on the openings. So shall we go to the next slide, sir? Yes. So there are different. This is the different types of panels which is in the market. The first image refers to the 4 panels. Is just a standard panels. It's made of the sheet metal. And the second image which refers to the vertical biparting doors. And the third image is for the painted panels, the center opening. And the last image is the small visions, the smaller visions. And in the bottom side, we can see the half glass and the framed glass, full glass, the panoramic glasses. These are the panel types which is based on the types, like the visions, which are based on the types and the painted stainless steel. By this category, we can have this variance. Can you go to the next slide, sir? Yes, sir. Yes, sir. So now we just see a general safety features about the users. So what when a user is going to use this elevators, what the general safety factors he should consider. That's what we will just look on to the next slides. As a first slide, next slide, sir. Okay, the first criteria, whenever a passenger or a user is going to use these elevators, when they make a booking, make the call booking, we need to be patient. Either it is also when we are making the call booking or also during the travels. That is the first important criteria which we need to apply. And second thing, when there is a children, we should not keep them alone while using these elevators. Always somebody should be besides them while using these elevators. As seen in the previous videos, as a safety factor, when there is a kids, always some persons we should require besides them. As a third general factors, we say always stay away from the doors. There is a safety factor also here. I can give 2 examples here. We can have a loose close, as when the car moves, the loose close can stuck into the panels, so it can lead to a fatal accident. That is the reasons we always suggest always stay clear from the lift doors. And as a last criteria, to reopen the doors, instead of putting the legs and putting the hands inside to reopen the doors, we always suggest to press the open button for opening the panels. This is a general user safeties which is given for the users. So can we go to the next slide, sir? Yes, sir. These are the don'ts which the users should not do. As a first image, it refers always the people's would always try to open the door. Some people will be like this. They will try to open the doors when they are in the landing zones or during the travel. Also, they will try to open the doors. This is also not safe. So this they should not do. And the second image refers if somebody will get into the cars and they will wait for someone, and to call that person, they will stand behind this landing door and car door, and they stop the elevators and they will wait for the persons. This also should be avoided. And in case of third criteria, when there is a power failure, during the travel in the car, when there is a power failure, there is no need to get panicked. So be calm, stay calm, and when there is a power failure, you just press the emergency key buttons, or there is a nowadays there is a ARB options which will take to the nearest floor and just open it. And the fourth criteria, when you get into the car, when somebody is not there, don't jump or don't play, or even for the kids, don't allow to do this. And as the fifth point, somebody can come with some tensions. So don't come and don't to show their hangers to the doors. So like don't kick the panels. This is all. This is also during travel also. We need to consider this point. This and all we should not do inside this one. And the last point, during the travel, don't lean onto the panels, because when you lean onto the panels, the door may get deflections, and there is a possibility of the panels getting derailment, and it can lead to an accident. Or sometimes there is a clutch inside this car doors which also stuck into the moving components, which also lead to accidents. So always stay away from the doors and don't lean on these doors. These are the basic safety factors which we need to follow during this using the elevators. So can we go to the next slide, sir? Yes. This is the slide which is for the technicians who comes for this door, the elevators maintenance. First thing, the technicians should always use their PPE kits as mandatory. All the safety kits they have to use as a mandatory, as well as this is for the mainly for the safety purpose. And second one, when there is a breakdown of the elevators, first thing they have to fence the elevators. This is the keeping the awareness to the passengers, as well as it is also a safety concern to the technicians also. And as a third point, always for the maintenance activities or when there is a callbacks, we always suggest to have a trained or qualified technicians to go for this repair works or the maintenance works. It will be the best options. And the fourth options, always to follow the instructions which is being provided by the manufacturers. So that criteria is more important. And always replace with the correct components, genuine components
from the manufacturer.
From manufacturers. And the last point, always to keep the periodic maintenance of these doors to have a long run and to have a safety factors. Yes, sir. Can we go to next slide, sir? Yes. So these are the don'ts which should the technician should not do. Always they should not violate the safety procedures. And the second thing, they should not violate any of the safety features. For example, in this image, you can see here, one side of this landing contact is not wired, and one side of this contact has been wired. So it is being bypassed. So this kind of bypassing, for example, this is an example like this. We need to follow all these safety factors, and there should not be any bypass should be done. And also they should always use the communication medium for emergencies. And when they are accessing to the pits, they should use the ladders. They should not jump inside this, and while they should not climb using some other components. They should always use these ladders. And our last 2 points is one is the mechanical, one is the electricals. So they should be paying more attention to this. So while doing this repair works or this checkpoint, they need to have this clear checkpoints, and they need to check all the points which is being specified, and also to check the wirings are properly connected, because this also lead to a fatal accidents. Is the next slide, sir. So now we just see the standards which we apply here. As a first point, most of only those doors which is there are a lot of automatic doors in the market, and all the automatic doors are not being tested or certified. But the doors which is being certified, which is being tested and which is certified within this CEN, BIS, GB, ACV will be the correct doors. Can you go back, sir? Yes, no, sir. Yes. And there are various elevator standards in the world, which is like IS, EN, GB, AS and GOES, etc. And all these norms are almost similar. So, and the IS is the most is applicable one for India, and the next upcoming common will be the ISO standards. Yeah. So this is the standards which is being used in the worldwide. This is the Europe, which is for the Europeans, and the Russian ones, the Asians, and the North American. These are the general standards which is being used all over this world, and which for us in India we follow as the IS 14665. That is applicable for us. Yes, sir. Yes, that is from our side, sir. So now I will transfer this next slides to Deepak.
Hello everyone, good evening to all the viewers. Let me start to explain the performance criteria of automatic elevator doors. Next slide, please. So in this, the first aspect we will see related to automatic door obstruction detection. So actually, part of automatic door function is to ensure that the door should not close if there is any obstruction. And once it is detected, and it has to be immediately retracted. And also, this is ensured by having a elevator car door sensor, which is basically functions as a obstruction detection, and this prevents the door from reclosing. And once the door doesn't reclose, the elevator also remains stopped. So this this can be done with the three different types of sensors. One is photoelectric. It is actually a 2D kind of sensor with two different sensors fixed at the bottom of the doors. As you can see at the first picture, there are two different lines. This is actually an infrared sensor, and these are located at a predefined location. So when a person or a user is trying to enter from landing to car door, and the doors are open, and in case of any obstruction, the landing door and car door stops movement, and it does not allow to get the user stuck in between or crushed in between. And the next sensor is a little advancement from the basic one. It is considered, it is called as 2D beams, and this has a little more advanced features, like the sensors is actually placed at two sides, and this is this ensures that there is a crisscross kind of beams passing from one side to the other side, and this ensures a little more safety rather than having just two sensors at the bottom level. And the more advanced sensors are 3D sensors. This actually typically detects not just when a person is just trying to enter, it will also detect a predetermined layout or an area. So this car door sensor is always fitted to the automatic car doors in every installation. So this is a kind of a safety feature also, we can say. Next slide, please. Mr. Tak, you can pause the video. So the next important aspect of an automatic door is this is also tested for impact resistance. Automatic doors are tested based on prevailing elevator standards for, as my colleagues have previously explained, for different regions, there are different elevator standards, and each elevator standard prescribes what should be the impact resistance. And this also has to be ensured that even after impact, the door should not come out of the elevator sill, and also it has to act as a barrier so that the person, it will avoid the person's falling into the elevator shaft. So I have a small video which took place in the past years. Mr. You can play the video. Mr. You can pause the video. So here you can see, though this incident could have been avoided, but this is the reason why even if a user tries to kind of vandalize or show his frustration due to unknown reasons, all the elevator automatic doors, landing doors, and car doors both have been tested for impact resistance. And you can see at the left side, the first image shows a pictorial representation of how what happens after an impact. Even after the impact, the door does not open, and also it does not allow any users to fall into the shaft. And the second image shows how a typical impact test is done in the laboratory when the door is designed and tested. So this we have a pendulum type of arrangement, and this, for example, for EN standards, the steel doors require a 45 kg impact test to be performed at the mid level. It is actually performed at the weakest section, which is actually the mid section of the doors. And also, after the test is performed, a deflection described in the standard has to be ensured. Even though the door doesn't come out of the guiding elements, if the deflection criteria exceeds, then even then it is considered as a failed design. So it's both impact and as well as deflection is very important. As you might have seen the video, if the door was tested for this impact resistance, at least the user would have not had to undergo the unfortunate event. Next slide, please. So here I'll explain about the performance aspects of the automatic door. So the right side image is a brief layout of the parts of an automatic landing elevator door. One is the mechanism. The second is the structural part considered as two uprights or vertical frames, and the horizontal one is considered as a lintel or a horizontal frame. And the next one is the moving elements, is the door panels. And these door panels are guided at the bottommost section in the component, the subcomponent called the sill. And the last one is related to toe guard. This is the basic layout of the automatic elevator landing door. And you can see each subcomponent is actually tested for both mechanical tests, electrical tests, durability tests, and also the fire test. So whenever a door system is designed, all this checklist has to be ensured, tested, ensured, certified, and then only it is released to the market. So the detailed testing of the subcomponents I'll explain in the next slide. So apart from this automatic elevator doors, it is also considered as a silent operation. This is also ensured by performing a noise test in an anechoic chamber. And the basic difference between manual door and automatic door is, in manual door you have to touch the doors to open. So whereas in automatic doors it is all controlled by the system so that the user doesn't have to touch it. So that is why it is considered as a touchless entry. So the final takeaway of this slide is performance and safety can be ensured only through defined test and certification. Next slide, please. So here, this is related to the landing door mechanism. And here, basically, we are checking the lock integrity. Landing door lock actually prevents the door from being opened manually. And this door lock is actually a very critical component, as this assures safety in automatic doors. And apart from a mechanical lock, there is also an added safety through an electrical switch. So whenever whenever a landing door lock is open, the safety switch also is activated, and this sends a door signal to the controller saying to stop the lift movement or the elevator movement. And the right side, you can see first is a mechanism, and the rectangle part highlighted is actually the switch and the mechanical lock. So hence the reliability and the quality of the door lock and switch is extremely important. And this is ensured in automatic doors is by getting a CE certification. Actually, a CE certification is a third party or a certified external laboratory which ensures or witness the test performed by the manufacturer after providing the design details and also the test reports. They go through a critical check, and even after a critical check, they mandate us to do a retest of the entire landing door lock in front of them, and then only they provide a CE certification. And every landing door lock of the product has a unique CE certification number. Here in the last below image, you can see a CE certification label pasted on the landing door lock. This actually provides a peace of mind to the user, and also ensures saying that this, apart from the manufacturer's claim of tested locks, even a third-party accredited laboratory also certifies that this landing door lock is safe. And apart from that, every year this CE certification, the auditor visits the manufacturing plant, performs a critical quality check of the components, and then only it is renewed on a periodic basis. It is not like just one time a door is designed, tested, and certified by a third-party laboratory, and it's forgotten. It is actually a periodic renewal process. So this stringent certification of CE certification actually differentiates between a good and a bad quality door lock system. Next slide, please. So here, this explains the second criteria of a door panel system for deflection resistance. In that, the first criteria is ensuring the gap between two door panels. Let's say for a condition where during maintenance of elevators, where untrained technicians or for an unforeseen reason, end user is trapped inside an elevator shaft, and when they're trying to exit, they try to pull the doors manually to get untrapped themselves. This is actually a risk to the both the technicians and also the users, being since there is a landing door lock provided in the automatic elevator door system. By pulling through hands, the gap between the door panels, though you can see a wider gap, people can try to get stuck in this between gap, and when this gap people get stuck, still the door panels are intact at the top, because there is a landing door lock which is preventing the doors to open, and this in terms considers the elevator system that the doors are closed and the car can operate. But for this reason, there is a special kind of test according to EN or IS or even American standards for different criteria, where a predefined load is applied at the bottommost panel and the midsection of the panels, and this actually simulates this environment, and it has to fulfill the deflection criteria. And the next thing is related to a gap between a door and a frame. This right side representation picture, you can for the benefit of public, they might have come across this kind of scenarios. So to avoid this during testing, there is a deflection deflection criteria mentioned in the elevator standards to ensure that the gap between a moving door panel and a frame does not exceed the norms. This thereby prevents the severance of fingers of kids or elderly people, which accidentally when gets trapped between the door and frame. So if this is tested according to the defined elevator standard, this ensures that this kind of accidents or incidents doesn't happen. Hence, adherence of the door panels to specified safety standards is extremely important. Next slide, please. So here, this is again a deflection criteria resistance, but it is to different subcomponents. Right now, we'll focus on the elevated door sill. You can see in the first image with the blue arrow marking, and this is actually considered, this is called as an elevator sill. So the elevator sill has a primary function to withstand the deflection caused by people and material movement for the period of 20 to 25 years of time for which the door system is designed. So a weak sill, actually, if it deforms, and it can form a trip hazard. So when people entering or exiting the elevator can fall either direction, and it can cause a serious injury to end users. Hence, elevator door sills must be thoroughly tested and ensure that the deflection is within the prescribed standards. And in this testing also, there are different guidelines or different set of criteria to be followed. One is a static load test, and another one is a dynamic load test. In static load test, the worst case load is applied on the sill for a predetermined timeline, and after a predetermined timeline, the deflection of the sill is measured. And in dynamic case, simulated a trolley kind of arrangement with the maximum load is applied, so that it is actually simulating material movement from landing door to car door and car door to landing door. These are simulated for a predefined cycles, and then the deflection criteria is not just measured at the bottom. These are measured in the three directions, X, Y, Z, and directions. So as I said earlier, this also is a very critical aspect, and automatic landing door system has to be tested for this basic test. And in the right side, it is related to the toe guard, where technicians, when they're working on an elevator maintenance, there can often be situations where the car is at a different level and the landing is at a different level. So at such times, there is a tendency for the technician's foot to fall in the gap between car platform and the landing floor. So a toe guard actually prevents this incident to happen, so that the technician's foot does not fall into the gap. So here at the bottom image, you can see the right side. When you see from the right side, a person who is trying to get into the car, since there is a toe guard, there is a tendency for the leg to swing between the car platform and landing door floor. And if there is no toe guard, and if the car accidentally starts to travel, again, there can be a serious fatality or injury by severance of foot or limbs. So it is important that the toe guard also has to be tested for a deflection test specified as per the standard, and it has to be complied. All these tests are specifically to ensure that the user safety is kept in mind. So as I said earlier, in an untested toe guard or untested door sill, or even the landing door lock or the impact. It is all designed, tested, and installed and maintained for the lifetime of the period to ensure the user doesn't have to face this instance. Next slide, please. So I'll hand over this slide to Mr. Giuseppe.
Good afternoon, everyone. Let's see together what happened when a fire occurs in the building and how the elevator is involved. So let's start with what is characterizing the door and the fire resistance and why it is useful to have a fire resistant door in buildings which are sensitive to the event of the fire. Next slide. Thank you. So what happens when a fire enters and occurs in a building? Usually the fire tries to go around the building and it spread horizontally and try even to go upwards and downwards. The shaft of the elevator is one of the fastest way of the fire to climb the building and to come from one floor to another floor. So the fire usually try to enter in the shaft of the elevator if there is the possibility. For this reason, in certain buildings, it's required to have fire resistance doors in order to avoid the spreading. In particular, usually when the building is more higher, the protection required has to be even higher. There are different kinds of door. The resistance of the door to the fire can be for a certain time, depending on the time it has been able to pass the test. Usually the typical resistance of the door is 60 minutes, 90 minutes, or 120 minutes. What does it mean? It means that if the fire arrives to the door of the elevator, the door will stop the fire from spreading for this time, which is the certified one. The automatic door typically are provided with the possibility to have it fire rated. The manual door, usually they don't have fire resistance. So let's skip to the next slide. Which are the regulations existing in the world and which are important to certify and qualify the fire rating resistance of the door? Today, there is the EN 8158, which is used in Europe, mainly, but even in other countries, typically around the world. Then there is BS 476, which was the norm coming before EN 8158, which is still used in some countries, typically even in India or other Malaysian country, but is disappearing step by step. Then there is UL10B, which is typically used in North America and some country around the world. And then there are other GB standard, which is the Chinese one, which is locally used, and IS 38093614, which is the Indian standard used for certifying the fire resistance locally. The classification of the fire resistant door can vary depending on the fire resistance that we want. Typically, E is indicating integrity, so the door is able to stop the fire from passing through the door and entering in the shaft. EI is insulation, so we stop the fire not only from passing through, but we insulate the internal of the shaft from the temperature rising. And then the last one is EVU, which is the protection not only from the fire passing through, but even from the radiation of the fire. Duration, as we say before, typically 60, 90, and 120 minutes. Which are the parameters that a door has to fulfill to be able to pass a test, so be able to fight against the fire? First of all, the first parameter is sustaining flaming on components. The second is gap gauge measurement, radiation flux, gas leakage, and fire hose stream. Now we will go deep into these key parameters. Next slide, please. So the first one, usually a fire impacting a door will transfer a big temperature to the door itself. The component has to resist to this temperature and has to be able not to let the fire go to. So if the fire is able to go through the door or to fire one of the components, if there is a flaming, continuous flaming for more than 10 seconds, then the door cannot be fire certified. What is important, why this is important, is because if the fire is able to pass into the shaft for a certain time, there is a high probability that it will spread within all the components that are inside the shaft. Typically, the fire is like a monster that tries to spread around the building. Next slide, please. What happened to the door during the fire event? The door, due to the fire, will start deforming. The deformation is a normal in every metal, in every kind of material affected by the fire. So the steel, the stainless steel, and all the different material used to build the elevator, if they get very hot, they will try to deform. It is important that this deformation do not allow the fire to pass through. So it is important that during the fire, there will not be spot or gap between the door element that let the fire enter in the shaft. For this reason, during the fire test, it is monitored this happening, and it is a failure if a rod of 6 millimeter or 25 millimeter is able to pass through the door. Because if one of these elements is able to pass through the door, it means that the fire will pass through. Next slide, please. Another protection that has to be, may be required to resist from the door is the radiation. Maybe the fire is not able to pass through the door, but we don't want that the people in the shaft or in the car are affected by the temperature, the radiation of the temperature of the fire. For this reason, there is this test, which is tested by sensor, where we detect how much radiation is passing through the door during all the time. The radiation has not to exceed 15 kilowatt for square meter, because this is the limit of tolerability by the human being. Next slide, please. Okay, this is an important news starting from the 90s. More the buildings were becoming taller. You can take as reference, for example, the Imperial Towers in Mumbai. More is not only the fire that can bring issue, is even the gas or the smoke generated by the fire. You can imagine in a big tower that on an intermediate floor, there is the vent of the fire. all the people which will be in the higher level of the building will be blocked by the fire. But maybe the fire do not arrive to them, but all the smoke and the gas will go up and create a disease, or will even make the people not be able to breathe and die. This is why the latest test methodology include the gas leakage rate detection. It is not allowed to a percentage, a quantity of gas exceeding 3 cubic meters for minutes to pass through the door. It is not taken into account the 13 minutes when the test starts, because it is the period where all the water that is inside the door will create a kind of smoke, but this smoke is not lasting for a long time. It will last until the water will disappear. Okay. So this is very important for the evolution of the elevator and the evolution of the fire protection, because the building are becoming taller and taller. Next slide, please. This is a test that is typically done with UL10B, applied in America in particular, as I said before. So what happened in the building? Usually it starts the fire. There is a lot of panic. The fire spread along a different floor, and then arrive the firemen. The firemen enter in the building with when there is a lot of smoke, and he starts with the water pump to try to solve the spreading of the fire and try to extinguish the fire. There is a problem that maybe there are people which are inside the shaft or which are in the elevator car. These people need to be protected by the firemen breaking through. So if the firemen try to extinguish the fire with the water pump, it has not to be able to break the door and reach or hurt the people which are in the elevator car or in the elevator shaft. This is very important. It is not applied on all type of fire rating, but it is giving an additional safety to the people inside the elevator. Next slide, please. Okay, the Indian elevator standard is usually mandatory when the building is more than 15 meters in height. So basically is more than 3-4 floors. Usually the manual door are not fire rated. So in case of fire rating, an automatic door is suggestible. There are accredited fire laboratories which are around the world and very famous that can certify and qualify the door to be fire resistant. The fire resistant has to be certified. There is no any fire resistance which is recognized in the market if it has not been certified by a notified laboratory. The classification, as I said before, are E, EW, EI. So E only integrity, EW integrity and radiation. EI, it means integrity and insulation. And EI door is even for default radiation protected. So if you want to have an insulation, you immediately get even the radiation protection. The duration is typically 60, 90, and 120 minutes, as said before. Next slide. Glass. Usually, as reported in the Indian standard, the vision panel should not be provided on power operated door. So usually they're not provided, and usually the door with the glass are predominantly not fire rated. There are in any case door which are having a glass fire rated, so that they can assure a certain resistance to the fire. This is an option, this is a variant that is available in the market. Obviously, even in this case, the fire rating has to be tested and qualified by a certification body. The fire rating glass is not a common glass, so is much more expensive than a normal glass, but is even assuring a very high protection. Next slide, please. Here is a summary on the future standard. So today, one of the main and the most famous standard available in the global market is the IN81 2050. In the future, there will be ISO 80100, which will be globally applied. So there will be an harmonization of all the safety requirement for elevator globally. The elevator is not different worldwide. All the elevators should assure the same safety level and the same protection. So we expect in the future to have one common standard that can be applied everywhere. This will have some exception because the interface to the building and the fire protection may vary depending on the country and on the building code. But we'll assure that there is a most easy certification of the product among country because the solution will be recognized worldwide. And it will be possible to have a global free trade. So it will be possible from India to export very easy because the solution will be recognized worldwide. The goal is to have one product and one norm worldwide. Thank you very much for your attention.
This is Tak Matthews. I'd sort of like to summarize what we have discussed so far. We've probably understood the importance of elevator doors and how it makes a difference to a building, the safety of an elevator. So how do we select the right door for an elevator? What are the principles on basis of which we do that? An elevator door is your interface between the landing and your elevator inside of the elevator car, the car door and the landing door. It's the interface. So if you are inside the car, the possibility of something happening to you on account of the elevator is dim, it's very low. If you're on the landing, something happening to you is also pretty low. So the door is what will ensure that you remain safe. And if you look at accidents and incidents around the country that have happened, and in fact, for that matter, around the world, it'll invariably lead, most of them would lead to the doors. And that is a crucial matter. And that is what we have tried to highlight in the webinar today. So when we look at the performance certification, it needs to have a life cycle. It is not that you just put a door for the purpose of installation and then, 5 years down the line, the doors are not working or are inefficient or the components are not strong enough. And I mean, these are elevators that have to last for the next 20 to 25 years. I mean, rails, doors are things which should not really have a problem, provided they have been designed and they are certified to the performance that has been established. CE certification, door locks and switch assembly, I would just go a little further and say that India also is getting into certification of door locks. And like was mentioned, we'll most likely be following the ISO 8100 Part 2. It is essential that we ask for safety test reports. A door is not just a sheet that you bend and then you form it into a door, and that doesn't necessarily make your doors. I've been hearing of doors which are 6 mm thick, made of 6 mm thick sheets. They obviously, without even getting into a test, will not be strong enough to handle the established and required elevator standards. Fire resistance, it is a subject which is very, grossly misunderstood. Just because you have a steel door or a steel plate in front of you, it does not become fire resistant. There is the material that is involved, the construction that is involved. And finally, if those doors are not certified, that means they are not being tested actually in a laboratory which is accredited to do a fire resistance, we have a problem. Now, the question then comes up is, when we get our doors, as a user, some of you are users and buyers on this group. Some of you are OEMs who get elevator doors from vendors. Some of you are probably even people who make elevator doors. The question that you need to be asking is, do your elevator doors meet the standards, meet the minimum requirements that have been set by the IS? Are they doors which will stand up to the certification requirements as mentioned by IS or even ISO 8100 Part 2? We need to always remember that the doors are our main line of defense against a dangerous scenario. We have our rest of the equipment in the elevators are as safe can be. And this is our interface between a user and the elevator car. With that, I would probably open it up into the question answer session. We have a question answer Q&A area where you can type in your questions. We have a number of questions, and what I'll do is I'll open up the questions and try addressing it as we go along. There are some general questions which I will address. The other questions, I think I will leave it up to the experts. So there is a question from Mr. Jagannath. What is the solution for rescue from a car if ARD gets failed and only one person in the bungalow or in the house? No one outside the lift, only one person inside the lift. The worst thing that somebody can do is try to self-rescue from an elevator. That is the worst thing that can happen. And there have been a number of instances when people have got killed by trying to jump out of a car or trying to rescue themselves. So this is a problem that has happened in private homes. And the solution for this is to ensure that your intercom system is connected to the outside world. That means your service company, when you press on the intercom or you try to get the intercom is at the call center of your service company. That is the only real option that is available. Of course, today with mobile phones, you need to probably check it. But then, like I said, the only way is an intercom which actually rings into the service center of your service company. For heaven's sake, do not try to do a rescue on their own. The next is a question, why can't we ban manual doors? This has been an attempt in India for the last 20 years, 25 years. However, it has faced a lot of protests saying that, these are cheap equipment and, this is for the lower economical strata, but I don't think that is an excuse because of the dangers that are involved. It's not just an excuse that can be acceptable. It's a fight that is going on, but as long as there is a segment that continues selling manual doors, who keep promoting manual doors, or hoistways that are constructed where only manual doors can be installed, we will have a problem. But this is something that we are trying to close out. Why manufacturers supply doors having opening less than 700 mm opening? I think I'll now leave it to the elevator experts to talk about this. Anybody want to take that question? Okay, then maybe I'll try to address this.
I will probably answer this a bit, Tak.
Okay, please.
Because while there might be sizes less than 700 mm, at least I can say on behalf of my company that our lowest size is 700. We don't have anything below that size. If there are anything available, what is important is, are the components that go into that door having the right certification, the right test reports? Is the entire door tested to the required standards? That is what is more important than the opening. So this is what I can answer from what I know as of now.
Yeah, I think I'll just collaborate it. I mean, I'm just trying to find the standard. The standard also says that the minimum door size has to be 700. And this minimum 700 door opening has to be for a private home. It cannot be for a public residential building. If you were give me some time, I'll probably pick up the exact standard and then tell you which standard it talks about. Can we get these PPT files for reference? I think the presentation is there on live. It has been streamed live, so I think you could probably access it from there. The next question is, does India have elevator safety guidelines or code which gets followed by elevator door manufacturers, and is it mandatory to follow these codes? Suraj, you want to address that?
Yes, I will talk about that. Yes, India does have safety guidelines and codes. You have to follow the IS standards. These are already prevailing and published by BIS, Bureau of Indian Standards. It's a big document. It covers all aspects of the elevator, including the doors. And is it mandatory to follow these codes? Yes, it is mandatory, but different states have different ways of interpreting these codes, and this is one of the weaknesses that we have in the system today.
What set of material gets used for making the door fire resistant to 2 hours fire rating?
The materials are usually steel and every other component that goes into it. But what's important is the way it is designed, the dimensions, the tolerances. This is what makes it stand out in terms of its ability to give the required fire resistance. You will see that it's not just a panel. There are bends, and it is not just a simple bend. These bends are made to some very exacting tolerances. This may not be obvious to a general user or a general manufacturer, but for those who design, they understand the importance of how important these tolerances are. The tolerance has to be extremely strict. If you remember what was covered earlier by Deepak and by Giuseppe about preventing the entry of flames, preventing the entry of gas, and all of that. So extremely tight tolerances, which call for stringent manufacturing practices to ensure sustained quality. Material is always the same. It's steel or stainless steel. But other than that, what's more important is the manufacturing accuracy and the design itself.
When we say door fire resistant, does it also imply smoke barrier also?
I will ask Giuseppe to answer that question, please.
Yes, it includes even a small carrier also, because it's always a part of the door. So it is not limited to the front or to the face of the door to the fire, but even to all the other components.
Okay. Request to provide little clarity on correlation with auto door and fireman switch. I think I will try to address that question. There is really no correlation. The fireman switch is intended to make the elevator operate according to the fireman's norm. So if you were to look at NBC section part 8, section 5A, it clarifies the phase 1, phase 2 operation. So the moment you have the fireman switch operated, the lifts are supposed to park themselves on the evacuation floor, and then the fire lift is available for operation. On the other hand, as was explained, any building above 15 meters is expected to have an auto door with an auto door. That is what the standards require. So the fireman switch and the auto door are not exactly correlated. But if you have a fireman switch and the door is not auto, it's not going to work, because you have the toggle switch to get the car, and if it's a manual door and it has not been closed, it's not going to work. So that's how it is. Can you give me standard elevator things dimensions as PDF book? I do not know what you mean by standard elevator dimensions. I would again refer you to NBC 2016 Part 8 Section 5A. It gives a lot of dimensions. It gives you a lot of references. Or refer to IS 14665 Part 1 to Part 4. It will give you a lot of dimensions. So I presume this is what you are looking at. Is fire rating mentioned on the door? I think I'll probably have to leave it. I'm not sure about that.
Yes, the fire resistance has to be labeled on the door. So there has to be a reference to the certificate release and to the notified body releasing it. So yes, it is labeled on the door.
And in addition to that, every manufacturer can actually give the certificate as a separate document, as a copy of the certificate. That's also possible.
Okay. The next question. What's the maximum gap allowed between the elevator platform and door sill as per international standards? To the best of my understanding, it is 25 mm is the maximum gap that is allowed between the running clearance is 25 mm. If this question is related to the manual doors, yes, the manual door would have a little bit more of a gap. However, if you look at the standards, it does talk about the minimum dimensions, and if those minimum dimensions had been maintained, that boy would not have got killed. So, I mean, there are simple ways of ensuring that this is taken care of, but then for that, you need to be aware of what the standard calls, and you need to be aware of the safety concerns that are involved if you do not take care of these matters. In most cases, door is not fire rated. Is it required to provide male, female profile even on non-fire rated? Then what is the purpose?
If you mean the female and male between panel and between frame, it is only to avoid the finger or of the people going through in between the panel. So if there is a female and male part, this will prevent the go through of the finger of the people or any other element.
Thank you. For observatory elevators like circular shaped glass elevator for the door would be curved shape. What are the additional measures or design considerations? If it is something that is expected to be fire rated, then the glass has to be fire rated. And trust me, they are very expensive. In addition to that, if you look at the standards, it also does talk about the strength requirements, the pendulum test that a glass will have to undergo for before it can be used as a car or as a door. Okay, I mean, there's a question I think it's incomplete. Mr. Hanuman Naik, if you could just re-enter your question, it'll become a little easier to handle because I think it's incomplete at the moment. Automobile elevator, is it preferred to have multi-panel center opening wherein there is also a possibility of vertical biparting? Is vertical biparting doors less safer as compared to center opening? I think Suraj or Abhay, I'll leave it to you.
Deepak, would you be able to answer that?
Yeah, I can answer that. See, whether it is a horizontal biparting doors or a vertical biparting doors, this is actually typically chosen based on the application. And this also, in design aspect, this is considered based on the shaft size. If there is a wider shaft, then you can go for horizontal biparting doors. And if there is a higher pit or higher overhead, then you can go for vertical biparting doors. For both the doors, as mentioned earlier, for it is covered under elevator standards. So whether it is a vertical or a horizontal, if it is tested as per the elevator standards, then it is considered as safe.
Yeah, I think one more concern is because it's vertical biparting, if the supporting structures fall, I mean, gravity will take over. Probably that is the concern. If it is center opening, there's no gravity that comes into play. But then it's a hoist weight dimension that will determine this.
Yes, exactly.
Mr. Hanuman Naik, there's again one more question, no license issued. So if you could just clarify on your question, we would be able to address that. How do we physically differentiate on appearance between a door certified and one which is not certified in terms of one, fire resistance, two, impact resistance? I mean, this is a question that I also would have. If I were to look at a door and I can't see the certificate or I can't see the notification, is there an easy way that I can sort of identify and say that, okay, this doesn't seem to be having a fire resistance and this doesn't seem to have an impact resistance?
For this, I can answer. To easily identify whether the door is fire certified or impact resistant, so there is a special label provided by the manufacturer, which is pasted on the mechanism or the door panel, which actually indicates the fire resistance done according to which standard and what is the fire certification number. And the same thing when it goes to impact resistance, there is a special a number specified saying that this door is tested according to which standard. This also is specified in the mechanism label, where you can see the CE certification mark. At the same place, you can also see the fire certification details.
Okay, I will be checking this on the next installations I go to. I mean, but I must admit that I don't recollect having seen it ever.
At least the ones tested has to provide this if they claim it is a fire certified doors.
Okay. I'm just trying to visualize whether even in ISO 8001 or EN 81, 20, and 50, it's a requirement that there is a certification thing on the door. We would have to check that. And yeah. I think it's a good decision that the door being so critical, maybe it is a mandatory requirement that behind the door, just like we have for glass, we probably should be having a way of identifying that this and the door has been certified to what. Okay. The next question is, can't a rule be formed from the government that architects, civil engineers should get the lift shaft sizing approved by the concerned state department? Many elevator companies face issues regarding the sizing of shaft and in order to install the lift. So it is a problem that is there. We have an NPC 2016, which is very elaborate in the recommended hoistway sizes and the number of elevators, the capacity, the speed, overhead, everything. It's very well laid out. Unfortunately, what happens is it's a reality that elevators become a low priority. So often after everything else is designed in the building, then they hunt around to find a place to install the elevator. And what you have mentioned is a point that I have been raising again and again. Even if you look at the high-rise committee of this Mumbai, it talks about everything but the elevators. So it is a problem that is there, and I think it's something that needs to be seriously taken off, because after the structure of a building, what makes a tall building possible are the elevators. And if the elevators are not taken care of, or the sizes are not right, or the number of elevators are inadequate, we have a problem. The sustainability of the building always remains a problem. Okay. Is there any possibility of SS finished door to be affected by corrosion? Stainless steel is supposed to be corrosion resistant, from my understanding.
Yeah, I'll take that question, Tak. The stainless steel doors, would it be corrosion resistant? This is a very relative question. So the SS stainless steel doors would be more corrosion resistant than compared to, say, a powder coated door. But is it corrosion proof? The answer is no. You can specify the door in any material you want, whether it is stainless steel 304 grade or 441 grade or whatever, but it complies with the metallurgical requirements of that particular grade. No steel mill ever guarantees that their steel mill is corrosion proof. What happens typically in the elevator scenario is when you install the elevator, and typically at the time of putting the granite on the platform, this is when the civil work is done and certain chemicals are used at the edges. Now these chemicals do tend to even damage the stainless steel as well, and this is something that is clearly mentioned even by the steel mills. The other time is during regular maintenance, where there are certain cleaning chemicals that are corrosive in nature even on stainless steel. So typically when an elevator manufacturer gives you an elevator and says it's a particular grade of stainless steel, the assurance is that it meets that grade. Whether it is corrosion resistant or corrosion proof, it all depends on what kind of chemicals the steel would get exposed to.
Okay. Arun, I think if you could just type your question once again, so we could address it. I'm sorry, but I think we missed that question. So if you could just type it once again.
Tag.
Yeah.
We have question on Facebook also. Mr. Sanket More asks that what is the minimum gauge for door panel?
Yeah. Could we just come to that? Let me just finish this. We have just got a few more questions here, and then we'll come to that.
Sure.
Okay. Arun, please retype your question, and then we will take it up. Does the fire resistance be given for Vittur for entire door or only header?
The fire rating is always for the complete door and never for either the header or the operator. I mean, the car door never comes under fire resistance. It's always landing door. Certification is always for the complete landing door.
Again, do you provide impact test certificate fire retardant? I think this is to Fermator and to Vittur. Do you provide test certificate for fire retardant, fire resistance, I presume?
Yeah, when the customer demands it, we do provide.
Yeah, so all your doors would have a fire resistance test certificate available.
Yes.
Does IS standards ask for gas smoke resistance of doors? If not, what should be the resistance? How is it measured or tested, and parameters to look for?
IS is not requiring for gas leakage. Today, IS is requiring for integrity mainly. So the parameter are the sustained flaming and the deformation of the door mainly.
Thank you. How do we bond glass in fire rated door?
It's basically one fire rated glass panel bonded to another non-fire rated glass panel with a PVB, polyvinyl butadiene. So it is a laminated glass.
Thank you.
And this is by the glass manufacturer.
Thank you. Any special safety norms and specifications for hydraulic home lifts in India? Where can one get these details? When you look at the home lift specifications that are there for home lifts, it mentions it. You are supposed to ensure that you meet that and you comply with IS 14671. So you need to work with, let me just get the standard, IS 15259, which is for home lifts. And along with that, you need to comply with IS 14671. Now, 14671 is IS 15259. Sorry, I got the number wrong. IS 15259 is for home lifts. IS 14671 will soon be replaced by IS 8100 Part 1, which will be adopted with the modifications for India. So this is how it is. So the standards are there. Is there any possibility if the doors can be manufactured in fiber or polymer materials in future? Wow. That's up to you. Okay. Abhay, it's a challenge thrown to you.
I think it will be possible today. It is not possible for fire rating because the polymer material get on fire and even the composite. So in terms of protection, these materials are still not at the level we expect, but sooner they will be.
Thank you. When you are doing local cladding of landing doors, you skin off the material supplied by the manufacturer. What guarantee do you have that the door is still safe or it should be retested for strength and fire resistance?
Local cladding of landing doors means I'm not able to understand that.
No, when they put a sheet on top of the landing door. So for instance, you have a stainless steel cladding on your door,
yes,
which is stripped off, and then they put another material.
See, the basic door is fire rated. Over that, you can put stainless steel or whatever to clad. As long as it's metallic, it's okay. It will not be tested for fire resistance.
To answer in simple terms, the fire rating is done on the base metal, not on anything that is cladded or stuck on top. So as long as the base metal is intact, it is fire rated. It will be.
Thank you. Okay, this is Arun's question once again. When we say fire resistant, does it imply smoke barrier also? So his question is it expected that the smoke flow into the car would also be controlled?
No, it is not smoke barrier. It's not a smoke barrier.
even if you have a higher degree, even if it is EW, right?
Yeah, if it's EW, yes. But if it's EI or E, no.
Yeah. So if it's EW, it will be a smoke barrier.
Yes.
So ideally, if you don't have a protected lobby, the fire resistance has to be EW.
Yes.
Right. I hope, Arun, that clarifies your question. So EI and E, as per what is happening in India today, no, it doesn't act as a smoke barrier.
Yeah.
My quotation is, what is the minimum gauge of stainless steel auto for auto doors? What is the gauge of the sheet for auto doors? What's the minimum gauge?
I think here the gauge mentions the thickness of the sheet metal. I think that is what is being asked. So here the minimum or the maximum depends on the type of performance that is required. So based on the ingenuity of the design, based on the capability of the overall impact, stress and fire resistance, different manufacturers will be able to achieve success at different thickness. The trick is, how do you get the certification in the least possible thickness? That depends on the ingenuity of the design and proprietary to each and every manufacturer. So how innovative are the manufacturers will decide the minimum gauge. Important thing is not what is the minimum gauge or how thick it is. It is what is the certification. Is it rated for 60 minutes, 90 minutes, 120 minutes, with smoke, without smoke? This is what is important, not just the thickness.
I mean, just to continue on this question. So if it is 0.6 mm, would it really manage to survive fire resistance? I mean, a certification, would it survive? Based on your experience?
I am not aware of any door with a 0.6 mm that will pass. Well, from what I am aware of, it would need to be at least about a millimeter.
A millimeter.
Yeah.
So fire resistance 1 millimeter is what is required. Less than that, most likely will not survive.
Yeah, unless, like the previous question, it is cladded. With the 0.6 cladding, it will pass.
Okay. What are the safety features should be in a firefighter elevator door? I think whether it's a firefighter elevator door or if it's any other door, the fire resistance as per the standards is what is required for the elevator door. And in India, we would require for above 15 meters, we would require the doors to be fire resistant. So I think that clarifies it. Whether it's a firefighter or it's a regular automatic door, it has to be fire resistant. Are all glass doors fire rated? How to confirm the glass door is fire rated?
Good question. The glass doors, if you see, we covered this in our presentation also. Different types of glass doors are there. Some are what you call as a small vision, which is a very small window in one part of the door. And then there is a half vision, which covers about 50%. And then what is popularly called as full vision, which except for a frame on the outside, the rest of it is glass. Typically, the mass volume of such glass doors sold in India, they are not fire rated. There are even some states in India, especially in the western part, where they insist on this small vision on almost every elevator that they install. But please remember, these are not fire rated. You might have a particular door from a reputed manufacturer, completely fire rated platform, but the minute that metal is replaced by a regular glass, it changes from a fire rated to a non-fire rated. So if you want a fire rated glass door, what is important is that instead of a standard laminated glass, a fire rated laminated glass must be used. That is point number one. Second, just putting a fire rated glass itself is not enough. This glass after fitting must be tested, certified and a fire certification obtained. Only when this is done can you say that the glass door is fire rated. Typically in India, the vast majority, maybe close to 98-99% of these glass doors are not fire rated, and one of the main reason for that is cost. The fire rated glass typically tends to be about 5 times more expensive, 5x, that is 5 times more expensive than the regular glass.
Just to add on a little more on that, we also need to have an intumescent strip, which is a type of strip which is put between the frame and the panel to seal under fire. The strip expands to about 10 times its thickness and it seals the gaps.
Just one note, The marking of the glass has to be visible in the glass according to the new norm. So if you have a glass, you should be able to recognize from the label in the glass which glass you are dealing with.
Thank you. No license issued for openings less than 700 mm. Less than 700 mm, I don't think, I think was clarified by Suraj, less than 700 mm doesn't happen. I think 700 is your lowest opening. And that too, if I'm not mistaken, it is approved only for a home lift. Above a home lift, I think the minimum opening required is 800 mm. I would suggest that you could probably join our webinar on March 10th, where we will be specifically addressing standards. And I will have my colleagues from the standards committee there who will be able to address these questions. So probably we could hold it for that particular day. For sill angle strength and fixing, is there any standard? The strength of the sill.
The strength of the sill, of course, there is a standard. You can also refer to EN 81-2050. So this standard explains how the testing has to be done and what is the criteria for withstanding the strength. Regarding fixing, it is depending on the application and the type of design of cabin or landing site. It can be any type.
Yeah, I think the other thing also that needs to be noted very clearly is the application. So if you have a sill where you have trolleys that are going over it, your regular passenger elevator sills will not take it. So application on what it is going to be used is also a crucial thing to be considered.
Yes.
Does instruments
Intimacy.
strips get get used? Intumescent strip get used in fire rated or for smoke resistant rated?
For both.
Could you address that, Abhay?
Yeah, intimation strip is what I told you just about. It expands to 10 times its thickness.
Okay.
Fire, and it seals the gaps. So this is used.
Okay.
And it's used in both.
Yes.
Fire rated and for smoke resistance also.
Yeah.
Is any standard considered in sharp edges designing of doors? I could see sharp edges in doors.
It generally has to be burr free during punching processes. I'm not sure whether there's a standard which says that.
Yeah, no, sharp edges are not allowed by norms. So you have to be sure that any cutting element is removed or a mitigation process is in place.
Okay, now I would request Hiren, if you could just check the other questions that are. Oops. In the meanwhile, I got a few questions here. Only landing door fire rated shall be enough. A car door fire rating is a technical impossibility, though NBC 2005 had mentioned car door fire rating. That was an error. Though it has been corrected in NBC 2016, there are fire authorities, CFOs who are still asking for 1 hour and 2 hour fire resistant car doors. I think we from the elevator industry need to clarify that technically car door fire resistance is not technically possible, neither is it practical. Is any standard considered? Okay, that I think we have covered that again. If there are no more questions here, Hiren, I will just open it up to you. If you could just pick up the questions from.
That question is already answered. That question was about the thickness of the material.
Okay.
I have one question for Fermater and Vitur both. Is there different type of doors for high-speed elevator? If yes, then what are the important points which buyer should clarify with manufacturer before placing orders?
Okay, I will answer that question. See, when you're selecting an elevator door, there are specific criteria. For example, height of the building, yes, it is a very important criteria, because as buildings become taller and taller, there will be more floors. And when more floors have to be accessed, the elevators have to become faster and faster. So doors are also categorized by different manufacturers based on the vertical speeds that it can sustain. So something like a 3 meter per second or a 4 meter per second, these kind of what do you call, technical specifications become very important. So manufacturer will have automatic doors which are designed for certain speeds, and you should always buy doors which can perform within that speed limit, vertical speed limit only. If you take a lower rated door and put it on a faster elevator, what can happen is, what you will notice immediately is shuddering. The metals will not be strong enough, it will not be thick enough to handle the speed at which the elevator goes up and down, and you will see the sheet metal juddering and vibrating and all of that. And over a long period of time, it will weaken the door and therein the elevator. So while selecting something for high rise, for taller buildings, please look at the speed of the elevator, and according to the speed of the elevator, please select the correct rated door.
Thank you, sir. Thank you for your.
The video would be is on Facebook Live, so you could see it there. Just to comment on the size of the door. So if you look at NBC 2016, it says that the opening shall not be less than 2000 mm in clear height and 700 mm in clear width. So if I just saw a comment also that there are doors being provided 650 mm, it is in violation of the code. So just clarifying that. So it is clause number, if you go to part 8, section 5A, and you go to page 41, you will find it there. It's at the bottom side of it. You will see it above clause D, constructor leaflet. So that is the situation. So anything less than 700 mm is not acceptable. What's the maximum noise level considered for operation of door? That I'll leave it to the experts.
Actually, in average is 55 decibel.
65 decibel.
55. 55. Yes.
Yeah, that's high performance door is 55 decibel in operation. But I think most of the standard doors and door operators would go up to 60 and 65.
Yes, but the German there is a German standard which say that in average should be like that.
Less than 50, yeah. Okay, I think the next time I'm struggling with my suppliers, I know what to quote. Small vision doors without steel grid is allowed. Is it as dangerous as collapsible door? So if you look at IS 14665, collapse vision panels are banned for automatic doors. So somebody who is providing a vision panel for an automatic door is in violation of the standards. I know there are 8 places in this country which are still insisting on vision panels. We need to remember that it is a banned thing. It is not allowed as per the standards. Now, having said that, if you do provide a vision panel, at least from a protection perspective, please ensure there's a grid inside. During the presentation, there was a mention of where the glass broke. Nobody replaced it. Somebody put his head in and the head got chopped off. It is not once or twice. It has happened a number of times. So you will need to provide a steel grid in any case. However, the first question itself, the premises is wrong because they are not allowed. What are the additional safety measures to be considered while using 3-phase door drives? Would somebody from Fermato Vittur address that?
There is, I mean, for 3-phase door drives, I don't think there is a specific requirement for that.
Yeah.
So there is no additional safeties.
Is male female door part of fire resistance?
Yes, it is part of the fire resistance.
Thank you.
Are we talking about, what are we talking about? What is it, male, female?
It is the
joining part when the doors come in.
The labyrinth.
The labyrinth. I mean, it all depends on the design. Different manufacturers take different approaches. These days, there are also fire-rated doors, EN certified doors available without a labyrinth that are also fire certified. For IS fire rating, labyrinth is a must.
Yeah.
But if you are looking for EN, then it is possible without a labyrinth also.
Okay. 600 mm and 650 mm doors is not as per codes. Yes, it is not as per codes. So it is. I'll just get the clause exactly. It is National Building Code 2016, Part 8, Section 5A. Chapter 6. Chapter 6. Sorry, I've got my code book all opened up and all a little messed up. 6.11 section D. So at the bottom of it, it reads, all landing openings shall be protected by gates or doors which shall extend to the full height and full width of the landing openings. These openings shall not be less than 200 mm in clear height and 700 mm clear width when the gates or the doors are fully opened. So I think that clarifies it. So whoever is giving a 600 mm or a 650 mm door is in violation of our code. If small vision panel not allowed, then how can reputed suppliers be supplying these doors? Well, I don't have an answer to that. The fact of the matter is,
I'll give an answer to that. Yes, it is true, small vision is not allowed, but there are certain states in our country where the inspectors actually ask for this small vision. It is specced into the buildings, and for that reason, anything other than small vision door will not get through. So in such reasons, in such situations, suppliers or manufacturers will have no option but to supply as per what is demanded in the specifications. But as manufacturers, what we always do, we do make it very clear that these doors will not meet the fire resistance test. It will meet all the mechanical and impact and deflection test, but it will not meet the fire resistance. So this is made clear to all customers at the time of supplying these doors.
So I mean, it just goes on. So above 15 meters, if you need to have a fire lift, you are already in violation. You are already in a problem where you are violating many other rules that are associated. Reputed manufacturers supplying 600 mm and 650 mm opening doors. I would not call them reputed anymore. If they are providing 600 and in violation of the code, then they are definitely not reputed. So I think, I mean, if you are a buyer, please keep away from them. If you are I think you better be taking it to the inspectorate concern and show that it is in violation of the code. I think this is the last question. What is the maximum door height that is available? I think between Vittur and Fermato, you can have a challenge on which is the tallest door that you guys have.
3,000 mm.
How much?
3,000 mm.
Okay, that's a small door.
Sir, but
maximum height.
Maximum 3,000 mm.
5,000 by 5,000 also it's possible, sir.
5,000 by 5,000.
Yes, sir.
See, I will put it with this way. There are standard doors and then there are special doors.
Yeah.
So when you have standard doors, it can go from say about 2000 mm to say 2400 mm. Okay, that might be what can be construed as standard. But when there are special requirement, if you remember the presentation, there was a category called special doors. So when there are special door requirements, then obviously the door can be customized to whatever is the height requested by the customer. So whether it is 3 meters height or 5 meters height, it's all possible, but it will be custom made.
Yeah, I mean, I think one of the tallest doors that I've seen has been provided by Pili for, I think, aircraft application. And that was like, I think some, God knows how tall it was. I just remember the picture. I don't remember the exact height. I think that was the last of the questions. Oops.
So I think there is one more question.
Yeah, Vittur has 650 mm and Fermato has 600 mm and 650 mm. One Italian company is offering even 500 mm opening automatic doors. I think we'll need to resolve this outside this session.
No, I can say for sure that Vittur does not have a door lesser than 700. The lowest we have is 700.
We do have 600 and 650s, but it is understood and explained that it is not, the customer wants especially that, and there is an indemnity clause on it. But this is very rare, maybe in a year a set.
Okay, and the Italian company is offering even 500 mm. Well, I mean, let's not go in that direction. Okay, so I think we have. Oops, there's one more question. We have vendors who integrate local door panels to branded headed doors to cut costs. Can this be avoided?
No chance.
It's a risk.
Yes, it's a risk, and it is something that we tried to fight, but it is not possible in the sense, if you go to court, the name of the company changes and the door is back in circulation.
Yeah, I mean, in fact, I have a couple of pictures where you can, of incidents which have happened, and the moment you dig into it, you realize that it is a question of mix and match.
Yeah.
And mix and match is a very dangerous thing to do in elevators, because the system, getting the system together, the system integration is the most crucial. You can have the best of components, but if you don't integrate them properly, you have the most dangerous equipment on your hands. And I think it was also mentioned in it, please work with the original integrated components. Do not cut, pick and choose from here and there. That's a dangerous thing to do.
I think there is also, the answer is also there in the question itself. It talks about cutting costs. Yeah. So if vendors are buying this headers from reputed manufacturers and making their own panels, there is a reason they want to cut cost. And what is the reason for cutting cost? You avoid the standards, and automatically the cost would cut down. So that's the main reason. But it renders the whole door unsafe, because, like Tax said, the door is required to work as a complete system, not in bits and parts.
Yeah, and cutting cost, just for the information of the 66 odd participants here, in the construction industry today, other than elevators, the cost of everything else has gone up. The elevators, despite the dollar rate having gone up, despite everything else still having gone up, the elevators are the only things where the price keeps going down. So I think we have a serious problem here. I think it's been a long evening, and I think we will now close. And before I close, just a quick update. These are the next webinars that have been. Just keep a look on our social media pages. On March 10th, we will have an introduction, the revision of Indian standards on passenger and good lifts. This is how India is adopting ISO 8100 Part 1 and Part 2. It'll be a good opportunity to address many of these standard-related questions. We would have 3 to 4 people from the standards committee on it. So, you can throw all the questions you want at them. It will be not just me working with one document. There'll be multiple people to address those questions. So please do not miss it. Keep a view on our social media pages for the links. Then after that, on March 24th, the time is 2 o'clock. There's a panel discussion on elevator and escalator safety. It is hosted by the IEMA, that is the Indian Electrical and Electronic Manufacturers Association, the elevator division. That's on March 24th, 2021, Wednesday. It's at 2 o'clock. So like I said, second Wednesdays and fourth Wednesdays, keep a lookout for webinars where IGMAI is, either it's an IGMAI hosted webinar, or it'll be a webinar where IGMAI is one of the sponsors. Like for instance, the IEMA Elevator Division webinar is being sponsored by IGMAI. With that, I think we come to the end of the session. But before I close, heartfelt thanks to the 4 panelists. And once again, I need to highlight that it's great to see 2 different competitors collaborating for the benefit of the industry, giving us and parting with their knowledge and with their experience. And I must say that the way you went about it, it was awesome. It was like an orchestra working together. Thank you very much. And then finally, a special thanks to Suraj and Abhay. You were the driving force behind getting your 2 companies to work together. Thanks a lot. Good night and have a nice day for the people who are not in India. Thank you very much. Keep in touch with our Facebook pages for the next webinars. See you soon.
Thank you. Thank you.
Thank you.
Thank you, everyone. Thank you.
Thank you everyone.